Welcome everyone who is joining, and we already have more than 100 participants for this webinar. We hope, I think it might increase to 200 or 300 by the time we get started. So, welcome to everyone. As you know, this is like the seventh webinar we are hosting in for from a Shardeum, in these webinars we keep it very simple. We have 1 hour or like literally sometimes 70, 80, 90 minutes where every developer once in a every developer comes, and the goal is that if developers are joining and they are participating, they get to learn a little bit about smart contract development. So that's why the webinars are called 0 to 1, and we are just providing that first step in learning. So in case you are a web 2 developer who wants to learn a little bit about Solidity, this is your chance. And in case you are a Web3 developer who is working on Solidity, and as you know, there can be a lot of different things you can do on smart contracts. That is the whole. Like in Web2 programming, you need to learn so many stacks and so many languages and everything. So when it comes to Web3, a smart contract is it's like your superpower. If you know how to write smart contracts for everything possible, then you have learned how to code. You can get a job. You can win bounties if there are developer bounties. Participate in hackathons even as a beginner, and or get an internship somewhere. So our goal is here is that once you learn in these webinars, you are able to get into any of these things. And I'd like to welcome Ravish. He is working with Lighthouse, and with Lighthouse, we have also had Shardeum missions, where the developers in the Shardeum Discord had to solve the challenge and win bounty. That was a very interesting mission, and just continuing our partnership with Lighthouse, who anyway integrated with Shardium. If in case anyone here is building on Shardium and they need to use IPFS Filecoin, like Lighthouse is one of the most efficient way to do that. And like I've seen it, I've seen the demos, and it provides multiple features. And I think we are going to see one of the use of Lighthouse here today in creating a very interesting smart contract, which is paid streaming platform. Something like Netflix, Hotstar, we have all seen. So we are not doing this on a large scale like that. But if anyone here wants to create a small, let's say just for your friends or just for a small hackathon, if you want to create or use Lighthouse, create a paid streaming platform, this webinar will help you do that. We are very excited to have Ravish. So, Ravish, please introduce yourself first, and I think then we can directly get into it.
Yeah, thanks, Chandresh. So, hey guys, I'm Ravish. So, I manage the entire product at Lighthouse. Along with that, my area of expertise lies in deep learning and Web3. And yeah, so I think along we will try to have an interactive discussion, and along with that, you guys will get to know everything. So,
Thanks, Ravish. So Ravish will start taking us through the webinar now. And meanwhile, since we have so many participants, the mic is mute for everyone. But feel free to use the chat, and that is the more efficient way. So feel free to use the chat while the webinar is ongoing. And any questions that come up, Ravish will try to answer them. And like between, if possible, if it's related to that, and if not, at the end we will look at the questions again, and Ravish will try to answer them too. So yeah, so we'll get started. Okay.
okay, so guys, I'm sharing the screen. Okay, so here is the schedule for the webinar. So we will firstly start with an introduction to Lighthouse, what we are building, and then we will go for a live coding where we will be building this pay-per-view service. After that, we will have a look at more use cases, then conclusion, and in the end, we can have a Q&A session. So in in the past we have seen a lot of vital information of humanity which is getting lost due to wars, even burning of libraries and such kind of tragic events. So right now with the modern technology, we have the ability to create permanent records, and that is what we are trying to achieve with Lighthouse. We are building a perpetual storage model where you can store your files for a very long period of time. So, what's the issue with the current Web2 ecosystem, and why do we actually need a Web3 solution for this? So, in the current Web2 design, you have first thing, the biggest problem is the broken URLs. So, even if right now I'm presenting on Canva, uh, you means this particular URL will not exist 2 to 3 years down the line. So, there is no permanence in the URL. So and this is also the case with New York Times articles. So around 25% of articles of New York Times are now inaccessible, means the links which are mentioned in those articles. Next is the content manipulation, and here I would like to show you the beauty of IPFS. So in the current web 2 ecosystem, suppose you built a website, it's pointing to google.com. You see a page. Oh, sorry, not Gmail. Yield farming and liquidity provider. Yeah, and Google, even if Google changes this page, maybe they remove this "I am feeling lucky" button. Even then, at google.com, you will see the page without this button. But what's gone is the page is changed, but the URL remains same. And this is where IPFS plays a good role in. In case of IPFS, even a slightest bit change in the content will change the entire URL, and that particular URL will remain for a forever. So for example, if I just upload a file in IPFS, so right now I'm using FilesDep of Lighthouse. So FilesDep is our interactive tool where you can play around with the features which are present in Lighthouse. So I'm going to upload a file, suppose sample.txt. I got a URL. I can view this file. It's this, and this is the CID. You see, it ends with 4xf. Now, suppose I change this particular file. Maybe I made this 120. Now I am re-uploading this file. Now, if you can see the hash changes. So with this, you have a guarantee that if I go to this particular URL, even 1,000 years from now, I will get the exact same file. And that's something which makes IPFS quite special. Now, let's go to the next page. Third problem is with the current Web3 ecosystem. So most of the NFTs which were built earlier are now no more. It means people were not uploading it on IPFS, or even when they were uploading it on means using IPFS for their NFT, they gave not the IPFS URL, which is the current standard IPFS, something like this. Instead, they gave URL of a particular company. So there was this particular collection called MeFit, which was around sold for 100 ETH. And today, if you go to this collection and view the image, it's not found. It's actually cached by OpenSea, but the original URL is not present because it was just uploaded, I guess, on the Google Drive or something, and now that particular link is no more. And even in case of FTX, which collapsed last year, the NFTs which were present on this particular ecosystem, the files are gone. The contract records remain, but the actual files are gone. So we need a permanent solution so that if a particular user is buying a particular asset, it should remain forever with that particular user. So now with the storage layer, we need persistent storage along with privacy, tamper proof, which IPFS offers, as well as fast retrieval. So at Lighthouse, we offer all four. So with our perpetual model, which is currently under development, your files will get stored for a very long period of time. And Yeah, I mean, we are building it for means lifetime permanent storage, but it's not technically that correct. So we mean by very long period of time we mean hundreds of years. And then we using our encryption and access control, which we will be using in this webinar. You can get the privacy in the decentralized ecosystem. IPFS, as I showed you, is a tamper-proof storage solution. And then using our gateway, you can retrieve file instantly, even 4K videos. So how are we building this permanent model? So we have a endowment pool, which is all governed by the contract, and that endowment pool, using the governance model, the funds which are present in that endowment pool will be staked in different protocols, and the return which will be earned from that staking will be used for creating the future deals once our deal of particular file is getting expired, and in this way we will be achieving the permanence. This is just an overview. There is quite more into it. So right now in the toolkit we have a SDK, which so there is one npm package. You have the coding. Right now it's for Node.js, and it works also on the browser, both server and browser. So now let's build this pay-per-view kind of model. So I think it's quite small. Can Yeah, I think now it's visible. So what we will be doing is, firstly, we will be encrypting a file and uploading it to IPFS. The key of that encrypted file will be splitted using threshold cryptography and stored in 5 different uh, independent nodes. And when someone has to access that particular file, those nodes will verify the wallet address of that user and return the file. So I think, let me show you with example. So right now I'm showing on UI, but we will also go into the coding part of this. So suppose I pick up a file, maybe this one. When I Right now I'm uploading it with encryption, so it asks me for a signature. So this signature is used by encryption nodes. So right now we have total 5 encryption nodes in which the key is splitted and stored. So, and using this signature, those encryption nodes are able to identify my wallet address. So now it got uploaded. So if I open this particular file on a public gateway, it downloads me a binary. So if I think it's not present here. So I cannot open this particular file. It's just a encrypted binary. But if I need to view this file, we need to decrypt it and then we can view it. So how we can achieve it? That's what we will be building today. So if I just go back to the flowchart. So right now what we did was, I was the owner of this file who uploaded the file. Our key is generated by our SDK, our random key using which this particular file was encrypted and stored on the IPFS network. So now IPFS network has an encrypted file. So any peer in the IPFS network can take the file from Lighthouse node into his node, but he won't be able to view that file because it's encrypted. And the IPFS node returns us a hash. What we did using Now what we did was, the key that was generated, we split it into 5 parts and stored it with the encryption nodes. Now to suppose now I want to grant access to this particular file to a user. So if there are different ways in which we can do it. First one is the P2P share, where I can have the wallet address of other user and I can directly share him. Another one is access conditions. So we can apply different access condition. So if we go to docs, and we will be trying this out also. So just a minute. So we can play around with different access conditions. Suppose if a person owns the NFT from this particular collection, then grant him access to this file. Something like this can be built. or even if you have a custom contract and you want the if the variable of this contract is this particular value, then you can match those values and grant access to file. Maybe if there is a native token, so suppose if the ethereum balance of this particular user is this much, then grant him access to file. This kind of conditions is also possible. Or something like a birthday problem where unlock this file for this particular user after this amount of block periods. Something like this can also be created. So now let's go to the pay-per-view. So in the docs, we have a pay-per-view section. You can also refer this, and we will be using these instructions. So to build a pay-per-view application, firstly, user has to encrypt and upload the file, which what I was doing using UI. So now let's go to the code. And the code is means directly ready. You just need to copy and paste it. I'm just building a new project. Initialize. Okay. Index. I'm just pasting the code, and yeah, that's it. Now we need 2 to 3 things. First thing that is required is the part2 file, which we want to encrypt and upload. Second will be the API key, and third will be the public key as well as the private key of wallet, the person who is uploading the file. So in this case, the wallet that has generated the API key should be same as the wallet which is here. So in case of browser, you do not need this part. So if I just go to the browser code example, there this thing is handled by MetaMask or any other browser. So if I just go to browser, so in case of browser, this will be handled by MetaMask in this signature. So you do not need the private key. But in case of Node.js, we will require a private key to upload the file. Yeah. So how do we generate our API key? So I will just go to use different folder. Okay. So you can generate API key in 2 ways. First is you can just go to this UI and generate it from here. You just need to see. It will download you a key and you can copy and paste it from here also. Another one is the CLI. So right now I will be using the CLI. It's already installed. So even if you in the CLI, if you just write the Lighthouse, we will get the list of all the commands which are present, and I will go for API key. Yeah. With this problem, it will not occur in your, it's my own system problem. There are some config issues. Right, so I generated the API key, and let me also show you the wallet which I'm using. So I am uploading using this 0xA3 wallet. So if I just create a .env file, paste the key here. Next thing is I need the private key to my wallet. Okay, I have already saved this wallet. I think this one, yeah. Okay, that's it. The third thing which I need is the path to this file. So let's try it out with maybe this video.mp4. So let me just have a path. PWD. So in case of Windows, you can give path in 2 ways. First one is the normal window, and second one is using WSL. So in both cases, the paths will change. So I will go for this one. And if you go for the first one, you need to replace the slashes to this thing, otherwise it won't work. Slash the file name. Let's go for this. Okay, so now everything is ready. Now let's try to, okay, now, and yeah, we need to install the libraries also. Let's go for that. I need to install the Lighthouse SDK. Yeah, after encryption and upload, we will deploy a contract and apply access condition using the contract. It's taking time. I think my Wi-Fi is full. Till then, I can look at some comments. Where was my link? I think not this one. New talks. Let's go back. I think this thing. Okay, it's installed. And I also need to install this. So ethers get automatically installed with the Lighthouse package. So no need for that. .env also. That's also done. Since I'm using normal Windows path, so I will go switch back to Windows and node index. Yeah, so file is now uploaded with encryption. So if I just open this file using a normal gateway, again you can see it's downloading me a binary. Now we will try to apply contract token based access condition and then view this particular file. Okay, and let me also give a brief of what this particular code is doing. So path is just the path of file. API key is just generated. Public key and private key, these are only used for signature. So what happens is, for uploading file to Lighthouse, you just need API key. But for saving that password which was used for encrypting the file into the encryption nodes, you need a signature to verify your wallet. And after that, you will be able to save it, shard that particular key and save it to 5 different encryption nodes. Okay, so for that we just call this signature function. It generates a message, which the encryption nodes use for verifying your wallet address. You sign that message, send it to the encryption nodes, a digital signature method, and then the encryption key is saved. Okay, so now let's go to the next step. Now what we will do is we will upload a NFT contract on Shardeum chain, and we will apply access condition on that particular contract and decrypt the file. So I'm using Remix here. I already have a NFT contract ready. So let me just compile it. Okay, it's ready. I think I have Shardeum tokens in this wallet here. And change needs to be changed. Shardeum Liberty. Mm-hmm. Okay. Inject. I need to deploy it with proxy. Proceed. Oh, provider not connected. It's not able to detect my network. Let me just reload it. Okay, remix is little slow. So let's go again. Contract NFT. Compile. It's ready. MetaMask. Okay, now it's connected. Deploy. Oh, sorry, I need to upload it with proxy. Otherwise, the owner of this contract will change. I won't be able to interact with it. So I'm doing this again. Yeah, now it's deployed. So let's have a look into this contract in the Shardium chain. My is on Liberty 1, so it's some issue. Okay, so contract is deployed. Now let's try to mint a NFT of this for this contract and apply access conditions. Maybe let me mint it for this particular person only. So I'm using this address and a string, any file. Let's take this file itself. Looks like some RPC error while format value. Let's try to call it again. Maybe this one is the owner of. Okay, let's go for another wallet. I see this. Mhm. Let's try it again. Right, speed. Let me check the owner. Oh, sorry. The owner of this contract. Oh, I was interacting with a different contract. Just a minute. I need to go for this one. Owner. Yeah, this one is the my wallet. So just by deploying with proxy, you become the owner. Otherwise, the owner was that 000 address. That's why it was showing that error. So now if I go to safe mint, let me paste the, okay, this is the CID. Copy the address. Okay, the transaction is confirmed. So my this particular wallet now owns a NFT. Now what we can do is apply access conditions. So suppose only the wallet addresses who own NFT of from this particular contract should access that file, and no other wallet address should be able to access the file. So let's switch to documentation and see how we can apply the access condition. So everything is just copy paste. We did the that work for you. So no, we will go for this code example. Apply access condition. I just pasted the code. Now what I will do is first is the private key. So the who can apply access condition in this case, the wallet which uploaded the file, means the wallet which is the owner of file can only apply access condition of that particular on that particular file. So when I was deploying the file, I was using this wallet, my 0xA31, which is also means here in the code example also. So only this wallet will be able to apply access condition, otherwise you will get a error. So let me just copy this. So, and the CID is here. This was the file which we uploaded with encryption. So on this particular CID we are going to apply access conditions. So I'm just replacing the CID. Now conditions. So let me just take the example of a NFT condition. So if you go to this code example in section, you will get the NFT condition, NFT based condition example. So I'm just pasting it. Now it changed. So since our contract was deployed on Shardeum chain, Liberty one, so I will use this thing, Shardeum Liberty one as the chain. I go here. Now I will be calling the balance of function from the contract. The contract is ERC721. Now the contract address. So if I just go back to Remix, yeah, I was interacting with. This is the contract address. And if the person owns at least one NFT from this particular contract, then grant him access to the file. That's it. So here we have an aggregator. So aggregator is used for different combinations of conditions. So suppose you can even have two conditions. Maybe one condition belongs to NFT and another condition belongs to a custom contract. In that case, you can just do the ID2 and you can here apply combinations like 1 and 2. So if both of the conditions satisfy, only then the user will have access to this file. So these kind of combinations can be created. So that's why we use this aggregator. Right now I'm going for one condition. Okay, now signature. So again, the owner has to verify his wallet address so that the access condition gets updated on the encryption nodes. Then okay, now let's just run this code. So okay, so yes, we got a success message, so it's now created. Now let's try to run it with two different wallet. In the first case, we will try to decrypt the file using this wallet which already owns a NFT from this collection, and then we will try to decrypt it with another wallet which does not own the NFT from this contract, and see how it behaves in both of those cases. So in case, so for decrypting the file, there are two ways. First is you can use the Lighthouse URL. So, and second one is you can code your own page. Let me just go to the documentation. So if you go to maybe browser decrypt file, so here you have the code example of coding your own decryption page. And right now I'm going to demonstrate firstly with the Lighthouse view URL, how it works there. I'm going on an incognito first, copying this CID. This is the view file URL of Lighthouse. So what this, so we already have run the same code example which I showed you. There we did all the coding work. So this particular URL at the user's end will first get the verify the wallet address, get the password, and then decrypt the file and then view it. So if I just go here, I'm doing the signature. So it's a video case, so it's taking a little time. But you see, the same CID which was not opening on a public gateway is now opening here. So if I just demonstrate you again, I'm going to a public gateway, a binary, but in this case, you have this particular video here. And so that's the difference. Now, if I try to decrypt this particular file with a different wallet address, let's go for that. The wallet which does not own a NFT from that collection. So I'm copying this URL. Let me just, so there can be sometimes caching issues, so I'll prefer incognito. Where is it? And this time I'm changing my wallet to a different one. Let's go for second. So this time my wallet account 2 is signing the message, and this account, now you don't have access to view the file because you didn't own NFT from that collection. So this is how you can create a pay-per-view service using Lighthouse. Let's do another experiment. Let's go for maybe do it to 2 NFT from this particular connection. So I will just update the condition. So when you rerun the code, the code overrides the older condition gets removed and the new conditions which are incoming gets saved. So now the old conditions are gone. So what I will do is, again, I'm going to the first wallet which holds 1 NFT. Now I will try to decrypt this again using this. Now you see account 1 is signing the message. Now he does not have the access because he owns 1 NFT, not 2. So this is how you can play around with it. There are more cases possible. So now I think you will start getting what I was meaning, what I meant by other conditions. So for example, this one which I demonstrated was NFT. Suppose you have a custom contract. We will also try this thing. We will try to deploy a custom contract and see how it plays around. You can have a balance of condition where you can, if a particular person owns this much amount of native tokens, then grant him access. If you have your own tokens, maybe ABC token, then you have to use this custom contract condition to create a condition like if someone owns 100 coins of my particular means asset, then grant him access. And this is time based. So time based works on number of block periods. So you have, so like in case of Matic, on an average daily there are around 40,000 blocks minted. So you can, if you want to unlock the file after 1 month, you just multiply 40,000 into 30. So you get how many blocks will get minted after a month, and based on that you can unlock the file after a month or something. Okay, so now let's go for a custom contract. So let me remove this. Okay, let's keep this, and I'm going again. So here I have a custom contract. It's just a basic contract, just a count. So initial value will be 0. Let's compile it. It does nothing. It's just increment, decrement, and count. Basic code. Now let's. Okay, the wallet is this. Deploy. Remix. All right, I will refresh this page. I think this will be gone. So if anyone has a question till now, we can have that Q&A. Then I will go for the custom contract. Yeah. Okay. Any questions you guys can type. I'm scanning the chat.
Hey Ravish. So I can notice one question. I think it's slightly up, which is, does this code have a GitHub address? And so I could notice that all of this code is available on Lighthouse docs, right?
Right.
Okay, good. So anyone who needs to access, they can just go to Lighthouse code and access it.
Yeah, everything is in docs. So if you are using React, then you can go for the browser code examples. So everything is just copy paste. You just need to paste it, change the API key, and that's it. In case of browser, and in case of Node.js, just change the private key with your wallet and change the API key, and everything will start working.
Okay. So one of the question I have is, since we were talking about the paid streaming service, right? Then here it's only about me having some tokens, not about me paying some tokens, is it?
Okay, so in terms of contract, you can create this payment model in different ways. Either you have your own coins, then if someone owns the suppose 100 coins of your asset, then you can, I will just show the custom contract, and you can create such conditions. Otherwise, if someone mints an NFT, you can charge for that NFT also. So if someone pays, then you can collect the payment, and you can use this NFT condition example. So it's kind of a pay per view. And if even the value of that asset can go up if the particular video is in quite demand. So even the value of NFT can go up in this case.
And when it comes to native tokens, so just an example, if we want to charge, we upload this tutorial, okay, just in case,
Mhm.
and we want Shardeum community members to pay 10 SHM to view this tutorial even after this live is over.
Mhm.
Is that condition can be added to this?
So right now we do not means go for the transaction level where we can get that if this particular person has made a transaction of 10 SHM to this particular user. That's why we made this way around, either in case of NFT, or you can have this this part, the custom contract. So you have to tune your contract in that way. So maybe you can create a custom contract where if someone pays to your contract, then you can keep his wallet address mapped to the amount of token he paid. And while you can just have to change the function name. So maybe get user balance, you just put the wallet address of the user who has paid, and you can check if he has paid 10 SHM or not. If he has, then you can grant him access. This thing can be possible.
Great. That sounds great. And I think one of the things you took us through, and which applies to a lot of streaming services, is time period, right? If I'm playing for Spotify, if I'm paying for Netflix, that month on month basis I have to pay. So in the time based condition, I could notice you give the example of greater than this block number, so it unlocks, let's say, after a month. So are there any time-based conditions? So one way I could think of is, higher than this and lower than this block number to make sure it is only available for a
Yes.
month.
There is one more way possible to create time-based condition like subscription model.
Yes,
So,
exactly.
but
So,
there you have to create a custom contract.
all right.
So suppose you can have a recurring payment where you can deactivate the subscription of a user after 1 month, and you can have call a function, maybe is subscription active or something, where you a user who is trying to get access to subscription will just give his wallet address, and the contract will check if his subscription is active or not, and the contract can return one or zero or true or false something. You can just compare it here, and in case the conditions matches, then he will get the access. And maybe if he did not pay it again after 30 days block period, then the contract will automatically deactivate the plan, so conditions won't match.
No, that's great example of having a streaming. Like I can understand that with custom contract the possibilities become a lot.
Yeah.
All right. I will. I think just check the. So one of the question I can see is what are the conditions for POAP? So I'm not sure if it's related to getting a POAP for the webinar or like so POAP would be in case of this smart contract. It will be conditions. It will be like equal to NFTs, right?
Yeah, we can have it in this way. Yeah, POAP is quite a good example. If someone attended the event, then you can grant him access to the webinar video recording, something like.
Great. I think we got it done very easily, and I hope everyone understood. In case anyone would have more questions, feel free to drop into Shardeum Discord server. There we have channels for testnets and also community channels. And in case Lighthouse team is also available. So Ravish, if you can let the viewers here know how they can reach out to Lighthouse team and you in case they want to.
Yeah, you can always, if you have any dev questions, always ping us on Discord. We are quite active there. Plus, you can even email us from email you will find on website, or you can join Slack. I think is not active at the moment, so Discord will be the best way,
Okay, great.
and even our Telegram, Lighthouse Telegram is also there.
So, so great. So to everyone who has joined us, thank you for joining, and thank you, Ravish, for taking us through this webinar. It was pretty quick, and I think the docs that Lighthouse have are amazing. That we can get so much information easily. Just go there, get the code, and work around it. So great job on making that happen, by the way. And to everyone who's viewing, thank you for attending this webinar. We are hosting this every alternate weeks. We'll have more webinars on more different ways to of smart contract development. If you have attended this webinar, you can find the link in the chat, a form link which is open for the next 10 minutes, and you will receive a POAP for attending this webinar, and we'll definitely try out a POAP based pay-per-view sometime soon. Like I'll check with my team and how we can get that done. So thank you so much, Ravish, and whoever is here, do fill the form to receive your POAP. Yeah, that's about it. uh,
Yeah,
oh,
thanks for having me, Chandresh.
yeah, bye, Ravish.
Bye.